Welcome to PyData Global. We're excited to have you join us today. Feel free to use the chat to connect with fellow attendees and share your thoughts during the session. If you have any questions, please post them in the Q&A tab and we'll address them, hopefully if we have time at the end of this session. Now it is my pleasure to introduce Cainã. They'll be presenting a talk on building production-ready research AI assistants with one command setup. So with that, I'll let you take it away. Have a great session. Let's give a warm welcome to Cainã.
Thank you. I just placed the resources, the GitHub link on the resources. Okay, so nice to meet you. Thanks everyone for joining the session again. So my name is Cainã, and today I'm going to talk about research AI assistant and how we can create one with one command line setup. That's a spoiler, it's like a Docker Compose app, but I'm going to explain how to implement such an application. So the agenda for this talk is basically a quick introduction about how does it work, lab research, and the routine, and also how a research AI system can help some lab groups, research groups, and also I'm going to talk about lab lanes. That's the name of this application, where I'm going to explain the features and also some challenges that I have faced. The implementation overview, and that's the code is right on the chat. Just to make clear, that's more like an idea and base starting implementation of it, rather than a full production-ready application. Not yet, at least. So I also want to share some challenges and grab some ideas from you, so how we can make it better. So I have created a backend application for this. It's working in Slack, it's working on a website as well, at least as long as my computer is up. And then I'm going to make the demo for you. So that's what we're going to discuss. So basically, I have the data source for the lab group, research group, for example, and have the scientific papers, have the media articles, blog articles, and so on, the web links. And these here is getting parsed by these tools, Landing.AI. That's a very efficient way to parse a PDF, including interpretation of figures. So that's the most differential feature from Landing.AI, I would say, and Firecrawl to extract it efficiently. So these documents is getting stored in a vector database phase specifically, and to get used, query to be used to answer the user question. So in this side here, you can have the user question, the user interface, the users asking the question. We have a front-end application here, just like temporary. That's not the focus of this application. I focus more on the backend using FastAPI, but just like to highlight it, how it's working, creating a Streamlit application. And basically have this API that identifies the intent of the user. If just a small talk, or if like a question about the research, if it is a question about the research, it's going to retrieve the document on the knowledge database of the lab, and then synthesize, summarize the answer, and return the answer to the user. So in the right side, I can see the actual graph using LangGraph of this application. So just a little bit about me. My name is Cainã, like I told you. I think the important thing here is that I have worked both in academic research and also in the industry. So that's why I'm very interested in working this application. This is a side project, totally open source, and I'm happy to have collaborators on it. So you can feel free to connect with me on LinkedIn. I'd like to start this application by this presentation by citing this quote here from David Pereira Neves. He's a professor of parasitology in Brazil. I have read this quote in one of his books more than 10 years ago, and it says, "Thus, in education institution, Teachers, students, and staff cannot see themselves as an island of wisdom or a group of privileged individuals isolated from society. Quite the opposite. They must understand that the work of each person has impact on the whole of the society. And the knowledge produced or shared must drive progress that benefits the entire community. In other words, knowledge must, above all, be guided by a sense of social responsibility. So this quote LangGraph marked my mindset of how we should share knowledge, and that's why I'm creating this side project application. So how does a lab routine work, basically? So in academia, we have the different from industry, the deliver of the academia is scientific papers. So they work hard for years to create, to produce research, high quality research, that papers, they are peer-reviewed scientific articles. They are like highly detailed, highly technical. Therefore, they're really hard to read for non-specialized people. So that's why I'm proposing this application here. And you also have the media coverage. So the media coverage are the news articles, the blog posts about a new research. So a paper just came out, and usually if the research is interesting enough, we have some blog posts, some press articles about it. The reliability of these articles might be good. Sometimes it might not be that faithful to the original research, but usually easier to understand, right? Let's focus on the society, not on specialized people. You also have some methods, protocols, and so on that you can also leverage in such application, but I'm not going to focus on it right now. So how do we make the research that's highly technical, highly detailed, accessible to everyone, while keeping the reliability of it? So one way, if you have just one paper, just a few papers, a few PDFs, you can use AI assistant, just like ChatGPT, Notebook, LM. They also provide the citations, the citation for the sources queried. So that's one really good option. But what about if you want to ask questions about the whole knowledge of the lab, the whole knowledge the lab has produced in the past years, for example. So based on our question, we want the system to figure out what are the papers in the media articles that should be queried to answer that question. So that's my envisioned solution here. So I'd like to have that every lab, for example, to be able to have their own database with the research data, the papers, the media coverage, protocols, methods, and so on. It should be easy to deploy the AI-powered QA research chatbot with citable sources. It should be customizable. So the PI is the principal investigators. They can define how to guide the instructions, to guide the response, and provide some useful instructions in additional overall context about the lab. And also it should be able to limit and track the costs, right, for this chatbot, right? With this, you can ask a question, just like simple question, just like explain the finance of paper X. That's quite easy to implement to answer, but you can also ask like more complex questions, comparing different students, comparing different studies, and also providing some date-time related questions. So summarize papers in the 5 years, compare the actual paper with how the media is reporting this paper, and so on. So in order to implement it, we have some several steps, right, to implement it. So the first thing is to parse the papers and also the web links with the articles, the blog articles. So that's I have done that in this application. We need to chunk this document, so the parsed files. We cannot just dump it all in the model because it's going to be expensive. It's going to generate some hallucinations. So we need to chunk these files. Then we need basically we're going to apply RAG, right? Retrieval augmented generation. So we're going to retrieve these chunks based on the user prompt. you need to augment the prompt with the retrieved context, and then generate answer and the citations in the sources queried. And then it's good also, it's important, it's essential to validate the quality of the retrieval and also the quality of the generation of this text. And all of this can be provided as a RESTful API, for example, using FastAPI, so I can connect it to different front-end applications according to the user. Let me just see if I have questions here. Okay. So the first thing that I have worked here is like parsing these files. And in order to parse this file, I have used Landing.AI. We can have like two main strategies to parse PDF files. You can use the PDF-only parsers, just simple Python libraries to parse it. Usually the quality is not good. I have some spaces, you then have like weird truncations and so on. If you use a visual-based parser, you're probably going to get like better results. And some services are paid, some services are free. Here I have tested Simple and also Landing.AI and Duckling. I'm going to talk about Landing.AI because that's the one I decided to use. But Duckling is quite interesting as well. I think the only downside right now is Duckling is not able to interpret, read the figures and explain the figures in details. And Landing.AI is doing that. So that's quite interesting. And for the URLs, you can use Firecrawl and also Duckling. They parse, they scrape the website and provide a markdown right to use for the large language models. So for example, so I was going to show about Landing.AI. Let's see if it's working here. So basically that's the API. I'm using the API for this, right? But the main, the better part of about it is that it explains in details the figure. So it interprets, it reads, interprets, and provide a text about it. It's not the caption, right? It's actually an interpretation of the axis, the points, the colors, and so on. I can show you in the text and the code side later. So that's why I have chosen these. Duckling's not able to do these specifically, but it's working good as well. So, and Firecrawl just using it is good enough for now. So we have the chunk approach. So far, the chunking, Landing.AI, they provide chunk right off the bat, right? We parse the PDF file and provide the chunk using a semantic logic. So far I have kept it, but I realized that some chunks are very, very small. So I need to combine them to have like a better performance, but I haven't done that yet. But that's a possible way to improve. For the URLs that provide some kind of markdown text, I'm using recursive select text splitter, just that splits by paragraph. If it's still too huge, split by sentence, then by words. It can have some overlap between chunks, so we do not lose too much the context. These are the main ways to main strategies to provide some chunking approach. I think like document structure base is the best one at least for this purpose. So that's something that it should be improved in this application. For RAG, for the RAG part, so far I'm not doing the ideal, the best solution out there because I'm using a common RAG approach. So basically I retrieve any document. I think I'm retrieving 30 chunks because I have very small chunks. And then I'm re-ranking it using a small light LLM and selecting the relevant documents. And then I provide this final filtered relevant docs to the bigger large language model so they can answer the user. So it works for like specific questions. But the main challenge here is that it's not a simple RAG solution, this application that I envision at least. Because let's see, for example, these questions here. Let's see what is PP3CA. That's a gene that from my PhD research.
that's easy to answer. That's going to find the PP3, it's going to find some chunks and going to provide an answer for that. But what about this question here? Summarize the last 5 papers. So we need we have some date time relationship here that we need to tackle using metadata, for example. And also you can choose metadata, some strategy. It's going to need either a full or summarized version of the paper, right? Have also some other questions. For example, what are the conversion findings across all of papers and cut traceability between X and Y? Did the media correctly describe results about the labor risk? So we can like ask comparisons and ask like about huge summaries of the research. In order to do that, the model needs to get to be injected. All this context needs to be injected and efficiently. Cannot like inject it out at once unnecessarily. So that's the main challenge here. So it turns out that this application is better to be considered agentic RAG. So I need to predate the retrieval strategy so far. And also we need to validate, right? It's crucial to validate if the retrieval is working as expected, if the generation of the answer is also working as expected. So for example, for the retrieval, we can see the relevance. All of these metrics, I'm considering a large language model as a judge because you don't have labels, but that's something that you can also work with. We can work with some expert to provide some labels and then provide like a better metrics. These metrics, we can use another powerful large language model to judge the answers, the retrieval, the answers of our application. So we can see how relevant it is to the question, if it has like enough context, if it's like has some diversity, is not pulling all from the same source, but also different sources. About the generation, we need to make sure it's grounded, the answer is grounded on the retrieved sources, not like making hallucinations. Also can like compute some citation accuracy if the citation is correct, and also if the answer is complete, it's leveraging all the retrieved relevant documents. This here is not implemented yet, so it's something that is pending for implementation. That's again just main idea in main framework so far. So the current status, like it's working, what's working well, the parsing is working quite well. The overall backend setup structure is working as well. So what needs improvement is the chunking, the retrieval mostly, and also it'd be good to have some easy injection of lab instructions and overall context. It is right there, kind of, but it's better to make it easier. For example, the guidance of the DPIs, for example. And what needs to be implemented in some guardrails, this agentic RAG, the validation system. And also, so far, it's like a 2-step approach where I build knowledge, the database, and then I use the chat. But this build knowledge, we can provide this knowledge as a service as well. That users can upload it and delete it like easily, these new papers and so on. And right now, we also have some cache, efficient cache, so we're not processing again the same files. So that's interesting. So let's go directly to the model, to the daemon. Let's see if it's still up, right? Because my light was out. I hope it's still up. Let me see my Docker. Okay, apparently it's not. Let's see. So basically what I have done is create a quick Streamlit app here. So I can, for example, say small talk is going to apply as small talk automatically. Then you can ask some questions. For example, what are the genes important for the human patient Amazon? So it's going to, this might take a while to retrieving, then selecting the, like re-ranking the retrieved documents, and then providing for the synthesizer to synthesize everything. So in the meantime, you can also that's the application that we have. So I can try it out. For example, let's say simple message here. The session ID, that's the basically what defines the threads, right? So you have the chat GPT, right? You have a specific conversation. So let's say FastAPI testing. Then that's how it works, right? We send a message, we send the session ID. So far, that's quite easy. I'm not using user and anything yet, right? So it's quite a starting application, right? So I have a response here. And so here we have the response as well. So basically, Finance is going to provide the answer, is going to link all the sources that was considered. We can have the PDF that was linked, that web article, this all related to Chagas disease, that's related to this this paper here, the protection in Amazon, right? Yeah, Amazon. And then this here is not necessary, just to provide like some reason and like specifically the page and everything. For example, we can also track the traces of it. So for example, let's update this here. So the lab might also be able to see what's inputted and so on. So for example, I first like said hello and then said hello. Let's chat. Let's chat agent. Okay, I think I need to update these again. The lesson. Oh, that's right. Because the last one I used a chat via here, but if this one probably is from Streamlit. Yeah. Yeah. So for example, here we have like the whole conversation, and you can see, for example, the sources. Here's the retrieval step. Then we have the synthesizer step. Then we have the all the sources that was considered for this application. But again, it's not agentic ready yet, so it's not going to be able to respond, to reply, to answer complex questions. It needs to be updated. But it also works from Slack. So for example, I can tag a bot I have created. I can say hello, it replies correctly. I can ask what is this gene, and then it replies and provides the references and so on. So last thing that I'd like to show is the parsing. In the repository, I have the notebooks. In the notebooks, I have some illustrations on how it's working. I think the README is quite clear about the two steps, how to set it up. If you have Docker, you just need to provide the examples, these environmental variables here. Not all we need OpenAI, because here I'm using OpenAI. I can extend it the support for other models later. But Firecrawl and Visual Agent, this is not necessary, and this is not necessary. So just like for providing the Slack and in their website domain specifically. On the notebooks, I'm going to split some time for keep some time for answers Q&A, but we have how it's working, and more specifically the Landing.AI. I just want to show that how powerful it is, because if you consider this a 2-page scientific paper, I have selected only 2 pages of it, and then have like the figure. So if you use like the classical parser, we see have a lot of space here. The figure is not explained. Here I have used these, and then I can see exactly how it's getting way more structure and of the explanation of the figure. So I have the title, the axis, the data points explanation, the design of the figure, and so on. So it's quite powerful, the interpretation of Landing.AI here. And the Firecrawl also, I'm using two-step here as well. I first parse it, but I have created a class that clean the article. So first it is in clean, that's everything's parsed. If I parse this argument here clean, I'm using a light large language model just to select the main parts of the article and exclude some ads, for example. I think that's it. I'm sorry about the incident with the light.